We're going to implement a model predictive controller for this temperature control lab where we have 2 heaters and 2 temperature sensors. And the thing that we're going to do first of all is regress some parameters from our model. We have K1, K2, K3, and then we have tau 1, 2, and we also have a tau 3 in our models. Okay, so those are our parameters right there. We're going to regress those by first of all running a step test on the device and recording the temperatures and the heater outputs, and then we'll use this to regress these unknown parameters here in our 4 differential equations. We have a total of 5 unknown parameters with 2 time constants and 3 gains, and we're going to minimize the difference between the measured and the predicted values. So the very first step in developing a model predictive controller is first of all to develop a model and fit the parameters. So this is going to be our very first activity right here, and then we're going to implement those updated parameters into a model predictive controller. So we're going to go step by step, just implementing it together. And the very first thing that you'll need is a temperature control lab. If you don't have one of those, you can get one. I'll just show you where you can go. Just come to the APMonitor.com website and you get all the source files that we're going to be using to start with here. This is the dynamic optimization course, and if you come down on the right to the Arduino lab, this is our advanced temperature control, for model predictive control, moving horizon estimation, and other advanced topics. There's also the more beginner basic. Okay, if you just come to heat.htm, and then that will bring you to the basic PID lab. Okay, this is the advanced one right here. You can get the files for this here on GitHub. So if you come here, we're going to be walking through these regression ones. Okay, so if you come to regression and then you look at second order MIMO, this is going to be a linear model. And we're going to walk through and start with the MATLAB files right there. So we've done regression before with this lab. We're going to be focusing on getting our regress parameters and then building a model predictive control application. So you'll need to get the files here, and you can do clone or download right here. There's the Git repository address, or you can download zip. So I'm just going to download zip, and I'll save that to my desktop. And then once it downloads, then I will extract it. Okay, so I'll go ahead and close those, and let me go to my desktop, and I'll just extract all, and it'll extract all the files. Okay, so this has all the different modules for running the advanced or the basic labs. Okay, and once this finishes, then we'll navigate to the regression folder, and we'll first of all run the step tests. I'll just open up Arduino master, and then in here I'll go to regression and second order MIMO. We'll go to MATLAB, and the very first one we need to run is generate data, and the second one we'll run is the TC Lab second order linear, so that will do our regression for us. So once this finishes, then it is going to generate this data.txt file, and then we'll use that for our regression. Okay, so MATLAB is going to open up, and then we'll start this running. Okay, and this is going to run for a total of 10 minutes, and there's some steps up and down of our heaters that you can see right here. You can change those if you'd like. I'm just going to leave them like that for this run. Okay, so it's going to start, it's going to connect. Now let's see what it's going to do here. It will bring up some message. Okay, if you get this message right here, it just means you need to go into your device manager and look for which port it's on, and then MATLAB will do the rest. So I'm just going to go to ports, and it's on COM4 right now. So I'm just going to type in COM4. Okay, and then it's going to update the code on the Uno board, and it says it might take a couple minutes. So I'll go ahead and pause it right now, and then once it starts running, then we'll proceed. Okay, it looks like it just started, and you're going to see the heater temperature, or the heater turn on, and then you should see the temperature start to rise. So we have our temperature 1, which is in black on top, and then our temperature 2, which is in blue. And you'll see a little bit of natural noise just because we're measuring this from an actual temperature sensor. And so you'll see the temperature 1 start to rise, and you'll see temperature 2 rise a little bit as well, just as some of the heat is transferred to sensor 2. But we won't see temperature 2 rise significantly until heater 2 turns on. So just taking a look at the diagram for this, let me go ahead and bring this up in. Okay, just coming back here, we have our diagram of what's happening with these. Okay, we have 2 heaters and we have 2 temperature sensors. And so let me bring this up as we're going. Okay, I'll put this off to the side, and let me move this over. Okay, there it is. Okay, so as it's going, we have heater 1 that turned on. Heater 2 just turned on as well. Those are both transistors, and they are connected, with some thermal epoxy to these temperature sensors. So that's temperature sensor 2 and that's temperature sensor 1. And these can measure anywhere between -40 degrees Celsius to 150 degrees Celsius. We should be within that range the whole time. Okay, so this is going to proceed and generate the data that we'll need to be able to fit our model, and then we'll use that model in a model predictive controller. So one of the things that we have here are some guess values. If you just want to use these, that's okay. I'm just going to go through the whole process here of getting these parameters and then implementing the controller. Okay, and as we're going, I'll actually go ahead and just copy this, okay, the generate data, because this is what we're going to use to build our model predictive controller. Okay, that'll be our MPC, and if you want to, you can create a separate folder. I'll just leave it in the same folder. And then the other thing that we'll need is our how long we want our horizon, and I'm going to call this mpc.csv. Okay, if you can't see the file extensions, okay, I'll show you how to get those. Here it says if you change file extension name, the file may become unusable. We know what we're doing here. We'll go ahead and click yes. Okay, but if you can't see those, go to View, and then come over here to Options, and here change the folder Options, come to View, and make sure this is unselected. Okay, hide extensions for known file types, and click Apply, and then you'll be able to see and change your file extensions. Okay, I'm just going to open this up with Excel, and once it's open, I'll just have time, and we'll just do 0, 1, 2, 4, 8, okay, and then coming on down, I'll just fill this down to about 60. So we have a 60-second horizon for our controller. We're going to be running every second, and we have unequal spacing on these time intervals. Okay, for the first couple we have 1, and then we move to 2, and then 4, and then it's 4 beyond that. So one of the reasons why we might want to do that is because we want to have 1 second cycle times. That's the very first step right there. That's a very important part of our MPC controller, is figuring out what our cycle time is going to be. And then we also want to figure out how far to go into the future and with what resolution, so we're able to track the dynamics and also making it to steady state. So you could add more here as well. We could go 60, 70. Let me go up just a little further. I'll go up to 200, okay, by steps of 10 beyond 60. And when I save it, I'll just click yes, that I want to keep that format. And then when you exit, it says, do you want to save your changes? You can click don't save because you've already saved it. And then if you come in here, you can edit with Notepad++ and just see, or some other text editor, and see that it's just a text file. Okay, now what we want to do is come into our MPC.m, and I'm just going to edit this with Notepad++ just as this is finishing running. So we're going to try to build our MPC application just while we're collecting the data. Okay, and we're just going to make a couple changes to this file. Instead of running every 3 seconds like we did for the prior application, we're going to try to run every second. Okay, I'll just update the comment there, 1 cycle per second. And so we have 10 minutes, so we're going to go for 600 cycles. Now instead of us telling what Q is, we're going to let my MPC controller tell us what Q is. So you can just delete all of this section right there. We still need these Q1 and Q2 just to be able to record what Q is doing for the plots, but otherwise we don't need to tell what Q is until the application starts running. And then same thing here with T1 and T2, and we have time as well. It looks like we have it specified twice. We don't necessarily need it twice. I may have just used it in 2 different places. Okay, and then here's our clock. We need to control it to every second. Here's where we build our plots, our real-time plots right there, just building the plots, and then we'll add points to those later. And then here's our main loop right here. Okay, so this is our loop where we're going to wait for a certain amount of time. In this case, we're just going to change this to 1 second instead of 3 seconds. And so it'll wait for at least 1 second. Okay, and then this is all just, making sure we pause for the right amount of time, recording the time, and then we read the temperatures. So what we want to do in this case is go ahead and first of all build our application, and then we'll insert our MPC controller right down here. After we read the temperatures, then we'll come up with the new control actions. Okay, so we'll put our MPC right in this region. So let's go up. First of all, I'm going to go up to the top, and let's go ahead and build our MPC application. The very first thing that we'll need to do is add path to the APM folder. That's where we'll have all of our MPC functions. And then the next thing we need to do is define our server. Now if you have a local server installed, you can just include the local IP address of your computer. If you don't have that installed, don't worry about it. We can use the public server. Okay, I'm just going to call this an MPC for my application name. The very first thing that I'll need to do is just clear any previous applications by that name. Then the next thing I'll do is load in my model, and I'll show you later how we're going to update this model with the new parameter values. Then we also have the data file that we created for the MPC, and that was mpc.csv. Okay, so now we have our model loaded and our CSV file loaded. And now what we want to do is classify certain of our variables as MVs and CVs. Okay, and parameters. So from the parameters section, we can take our MVs, and so those are going to be APM info. We're going to classify these as MVs, and this one is going to be Q1, and then we also have Q2. Okay, this is getting close to the end. I only ran it for 600 seconds, so you can see the plot over there on the right. It's getting close. Okay, and then the other one that I want to declare are my 2 temperatures, and that is going to be CV and a CV for TC1 and TC2. Okay, and then we can set up certain options as well. And here I'm going to do APM option, and this is going to be apm.imode. I'm going to change it to model predictive control mode. Next thing I want to do is also, I can switch my solver. For example, if I want to switch it to IPOpt, I'll select option 3 here. And then I want to turn on different options. Okay, in this case, I'm going to have, first of all, q1.status, and I'll turn that on. So then the optimizer can start using that to drive me to a set point. I'll do the same thing for Q2. I'll do the same for TC1 and TC2 as well. Those are going to be my values I'm going to try to drive to a set point. Okay, and then I will also want to turn on the feedback status for TC1 and TC2. That means I'm going to use the measurements that come at it. Okay, so I have all of this configured. The other thing that I need to do is set up some set points for my TC1 and TC2. And this one is going to be a set point high. Okay, I'll have my set point high values. And let's say I want to drive these to 40 and 30. And then the lower, okay, this is going to be set point low and set point low, and let's say that's I'll do 39 and 29. Okay, so that's going to be the range it's going to try to drive it to. It's going to be between 39 and 40, and then for temperature 2 it's going to be between 29 and 30. Okay, so I have those configured, and now what I want to do for creating the MPC application is come down below and just insert measurements, solve it, and then retrieve the new Q values. So I'm going to come down here to my loops, and right after I get my temperatures, I'm going to insert those temperatures into my application. I will do that with APM and this is going to be TC1 is T1 II. Okay, and then similarly I have T2, which is going to be TC2 in my model. And then I'm going to solve my model predictive control. So I'll give it the command to solve it, and then I'll retrieve the solution. So in this case it's going to be Q1 II equals, and I'll use the APM tag. I'm going to get the tag value for this is going to be Q1.newVal. And then same for Q2. Okay, so I have inserted my two temperatures, I solved my MPC application, and then I retrieved my two Q values. Now I need to implement those. Here's where I adjust the power level. I'm just going to move that down. Okay, so I'm going to move it right down here, and then that will implement my two heater values. Okay, I think I'm about ready. Now what I need to do is just get my new updated parameters from my estimation over here on the right. So there you can see the two trends there. There were some step tests that I gave, with these heater values, and then some random, very frequent updates. And let's go in and see if we can. I'm going to close this. I think my MPC is about done. We may have to tune it just a little bit, but I'm going to come in here and now look at my, let's look at my data.txt file. So there's all my raw data right there. It looks like I don't have this thing quite right here for generating the data.csv file. Okay, so it looks like it's invalid precision. I need to do something else there. If you get that error, I'll update it, and it should generate data.csv automatically for you. But if it doesn't, you can take your data.txt and add time, and then Q1, Q2, and TC1, and TC2. Okay, so those are, you just need the header for that. Okay, and then we'll come over here to TC Lab second order linear, and I'll run this, and this will use the data.csv file that you saw right here together with that model that we described earlier, those 4 differential equations, and it will try to optimize, so adjusting those parameters and give us the best parameter values so that we are in best agreement with our data. Okay, and then we'll use those parameter values for our model predictive controller. Okay, so it looks like there's an error here. No, that was from my other one. I'm trying to, okay, so here are my K values. It looks like I had from data.csv, it looks like I had a problem with the at the very end of it. So I was just trying to CSV read and then be able to plot the results. But let's just see what's going on with those. Okay, so I'm going to open up data.csv and look at that one more time. Okay, that one is still empty. Oh yes. Okay, so I need to go and delete this one. I updated the header for that. Okay, and it looks like MATLAB is still holding on to that. So, okay, I think I just need to close that. But MATLAB is holding on to the file, so I'm just going to close MATLAB. Okay, there it is. So I'm going to rename this as data.csv and then come in here and open this again, and then I'll rerun it. Okay, so after this opens up, we'll hopefully get better parameter values, and then we'll update our model file for our controller. Okay, so here it is. Here's my parameter regression, and I'll run it one more time. Okay, so it'll take 2 seconds or so to solve it, and there you can see the overall fit of how my model predicted with my data. You can see there's a little bit of an error here, just as it was a little bit cooler in this room than I said was my ambient temperature, so this one heated up a little bit. Okay, this is a number of minutes, and there you can see my Q values as well. Okay, so there is my fit, and I'll go ahead and close that. The thing that I'm interested in is this are these 5 parameters right here. So I'm going to copy these, and then I can close this out. Okay, once I've copied those, I come into my model.apm file, and then I just need to update those parameters. So I had some initial guesses there, but I'm going to just delete what's there and just include these new parameters. Okay, and I'll delete that because that was for, we had some constraints there for my optimization, and I'll just put these under constants now. So now we're moving in that same model. We're going to use the same model we used for the parameter regression, and we're going to use that for the model predictive controller. So here you can see my 2 MVs, Q1 and Q2, and then my 4 differential equations along with my 4 variables. The ones that are controlled variables are these, the TC1 and the TC2. Those are my sensors. Okay, now let's go back into my model predictive control, and I sometimes have errors when I try to do this. We'll try to figure out any errors. We added the application, we added some basic tuning, but we may need to add a little bit more or adjust it as we go. Okay, so let's go ahead and just try to run this. I'll go ahead and close these other ones. We don't need those anymore because we have our new parameter values. Okay, so this will run, and let's see. Look at my device over here. It looks like it's all ready. and it looks like I have undefined function or variable APM option. So I think it's APM option instead of APM options. So let me go back into there. Okay, I have APM options. I'll just go and do a find and replace on that. APM options. Okay, I'll replace everything that's plural there. Okay, there's my first correction. Let's go through this some more and see what else we can find. Okay, it looks like it's connected, and ooh, power level 400%. So that's not quite right. We can't have a 400% power level. That's going to cause problems. We need to constrain our MVs. Okay, let me go ahead and just break that one. And let's do, put this in, we can't have anything go below 0 or above 100. So let me add some constraints there. Okay, I'll just copy these for the options, and I'll put in the upper bound for both of these. Change that from status to upper, and change those to a 100, and then change the lower bounds as well. I went down too far. Okay, so we have the upper values, and then we'll also have some lower values of 0. So I'll just change those right here in the script. Okay, so that was the very first correction. We'll see if we need any others as well. I'll run this one more time. Okay, it's going to connect to the Arduino and then start again. And again, we're trying to go up to a value of, okay, this is going to be a value of 40 for temperature 2, and then for temperature 1 getting up to a value of about 30. Okay, now I want to see what the application is thinking, because it looks like it's going a little bit too sluggishly here. And so I'm going to go ahead and just stop this again, just Control C, and then come back in here and let me do one thing on this. I'll open up a web viewer. Okay, so if you scroll down into the loops, and I'll put an if statement in here. So if II, that's our cycle counter, equals maybe cycle 10. We'll open it up after 10 cycles, and we'll open up the web interface. Okay, and that will help us see some of the parameters and be able to see some of the tuning that we need. It looked like it was going up a little bit too slow, so I'm going to adjust the time constant for my reference trajectory. So if I come up here to some of my options, I have TC1 and TC2. Okay, and this is going to allow me to adjust the time constant for how fast I want it to get to the new set points. And let's just change these to 10. So it says in 10 seconds I want to be about 63% of the way to my new set point. I'll run this one more time. And we'll also see the web viewer open after 10 cycles of the controller. So about 10 seconds into it, it'll open up a web page. It'll open up in your default browser. Okay, now we can see what is going on with TC1. So it's trying to follow this reference trajectory right here. You can see the set point high and the set point low, and you can see that the value is going to start climbing, but the controller will know that it can't go as fast as we're asking it to go. So we're asking it to go much faster than it can actually go. Let's check out temperature 2 as well. Okay, so that one's trying to get up to between 29 and 30, and you can see the raw model prediction, which is in the blue, and then the biased model. So there's a bit of noise there. We get some just natural variation from our temperature measurement, and so it's just updating as it goes. Let's check out temperature 1 and see how that one's doing. Okay, it looks like it's following this trajectory and coming up, and it's going to try to cut back on Q1 and Q2 at the right moment. Okay, so this is looks like it's equal to 0, so we still have the feedback status on, and it looks like we need to turn that off for Q1 and Q2. Okay, but you can see the move plan that it's making right there for Q1 and for Q2. Okay, and I can turn off parameters as we're going. So we don't want to use the measurements for Q1 and Q2. We're giving those. So I'll just change that to 0 and to 0, just so we don't use the measurements of Q1 and Q2. Okay, and there is Q1, and now it's progressing. It's not using those measurements anymore. Okay, but you can see the move plan for the heater. And one of the things with model predictive control is it's going to use everything, it starts at 0, and then it's going to make a move, and then it's going to implement that. Anything after 0 is just going to stay static, but you can see it's doing constant adjustments there just because the measurements are changing a little bit. Let me come back to the controlled variables here. Here's TC1. Okay, so it's staying within that set point high and set point low region. Okay, when it's below that, it'll make a little bit of a move up, but generally it's staying within that 1 degree band. Now I can change this if I want to come in here to set point high and set point low, and I could change that to 50, for example. I just change it to 50, so it's going to widen that up. And then let me change the set point low as well, and I'll change that to, let's say, 49. Okay, and then it's going to make another move trying to go up to this new range here. Okay, and try to drive it up. Let's go take a look at our MVs again. And here is Q1. Okay, so you can see it's making a move. If you do get this orange thing, it just meant it was trying to write it when you were reading it. You can just click refresh, and it should bring it up again. Okay, so it's at 100% right now, and it says in about 30 seconds it's going to drop down to about 45% heater. Okay, so it's going to stay here as it tries to track up. You can go to dashboard if you want and see links for all of these. Okay, so there's a set point change still coming up, and it's getting ready to transition down to a value of 45. Okay, so it looks like it's there. It's now around 45. Let's see the real-time plot. Okay, so you can see it had come up. It stayed right around 39, and now it's going up to about 50. And you can see the Q values that were implemented. Okay, this doesn't show the forward prediction like the web plot shows. It just shows the historical values. So the web plot can show not only what happened, but also where it's going. And so as you update things here, you'll see it update in both places. Okay, so what we've done is we've implemented a model predictive controller. Overall, what we did is we took the model that we had, the 4 differential equations with the 5 unknown parameters, and we updated those by running some step tests, used the step tests to come up with these new parameters, implemented the new parameters in our model, and then in MATLAB we implemented the model predictive controller and are now running it to follow these different set points that we have. And it looks like we are able to track both temperatures. So we were trying to meet a set point of about 29 to 30 for temperature 2. And then we started off between 39 to 40 and then moved up to 49 to 50 for our temperature control for number 1. Okay, so model predictive control, kind of the nice thing about that is that you're using a model instead of needing to do heuristic tuning. It has an idea of if you move something now, it knows what's going to happen, 100 seconds from now, 200 seconds from now, and can make moves accordingly, knowing where it's going, not just where it is right now. So it's like projecting off into the future. We're using optimization. The optimization solver has to be fast enough in order to be able to find a solution and be able to implement that. Okay, but it looks like we can do that at 1 second intervals with MATLAB and the Arduino connected through a serial connection. Okay, I hope you enjoyed this video. This is a little bit longer than typical, but I just wanted to show you step by step on what it takes to implement a model predictive controller in MATLAB. And you can do it for other applications as well. We've used it on many other applications, both in MATLAB and in Python. And so basically the limit is really if you can describe it with a model, and then you can apply the optimization principles of model predictive control and control it in real-time systems.